Hello, everybody. Today we are going to cover hypothesis. This is chapter 7. Just a little bit of a heads up. Things are going to be getting a little bit more challenging from now on. I'm not telling you this to scare you. It's just some of you, especially any of you that never took statistics before. Um, you're going to deal with some new concepts and some new terminology that you never encountered before. So please just allow yourself some time to adjust. The Every single day that goes by, the more you read, the more you practice, it's just going to eventually become, if not second nature, you're definitely going to feel a lot more comfortable. So allow yourself, it has a little bit of a not very deep, but deep enough learning curve. So, and everybody's different. Some of you just gonna get it. Some of you gonna say, "What in the world is she talking about?" Um, so just give yourself some time. All right, one more quick note. On chapter 7, at the second page, you're going to find that the author decided to finally talk about samples and populations. Now, we already covered that very early on in the semester. So if you feel pretty comfortable with what a sample is and what are populations and all that, you can just breeze through it, just skip it, whatever you feel comfortable. If you feel like you need a little bit more to get a better grasp of those concepts, please feel free to read it. So, our goals for today. First of all, we're going to cover what is a hypothesis, what are the different types of hypothesis. We're going to talk about things like the null, the research. We're going to talk about directional and non-directional. And then finally, we're going to talk, well, what criteria, how do we judge, how do we evaluate a hypothesis? Because we want to form a good hypothesis. So let's get started. What is a hypothesis? As you're going to see here, it says it's an educated guess. It doesn't say it's a guess, it says it's an educated guess. The reason that it says an educated guess is because researchers don't just wake up one day and they say, I want to study if there's an association between variable 1 and variable 2. In order for them to do the research, they need money. And institutions usually don't just hand money out. You have to prove them that you making a pretty valid argument. So in order to prove them that there's need for you to research what you're suspecting, you're probably going to have to read pre-existing literature. So you're going to go ahead and read other research, and usually towards the end, the discussion part of every research project, and that's why on homework 2 I had you to actually find a research paper, and the idea is to just familiarize yourself with the different components that goes into a research project, right? You introduce what you're going to do, then you're telling how you're going to test your hypothesis. You're going to in your method sections, you're going to cover your statistics, then you're going to state your results, and finally, you're going to talk about what you found. And you're also going to talk about what you hoped that you would find and you didn't find, and maybe what would have improved your hypothesis. So you tend to analyze, and kind of reflect on the entire experience. So someone else, another researcher who's reading your research paper, is going to get an idea and he's going to say, look what this person is saying here. I think I can test something new. So you're doing this, and that's actually part of your literature review. Any of you that's going to continue on with your master's or a PhD, you're going to have to write your dissertation or a thesis. You're going to have to come up with an educated guess, and then you're going to have to prove it. But in order for your professors to approve your educated guess, they're going to tell you, well, go ahead and do a literature review. Give me that, provide me that there is indeed a need to research what you're thinking that you're going to find. Okay, so that is why it's an educated guess. So we're having two types of hypothesis. We're having the null hypothesis and the research hypothesis. The null hypothesis, as we're going to see, is a statement of equality where the research hypothesis is usually either directional or a statement of an inequality. So let's get started with the null hypothesis. First of all, um, what does it state? The main thing and how do you identify a null hypothesis is usually you're going to see something as no association, no relationship. So the null hypothesis always states no relationship, no association between two, three, or more variables depending what you're testing. Here are some example of good null hypothesis. The first one says there is no relationship between problem-solving ability and overall intelligence. The second one says there is no difference between aquatic physical therapy and traditional physical therapy used for the rehabilitation of a knee injury. And finally, the third one says there will be no difference in the average score of Olympic athletes and non-physically active individuals on VO2 tests. Now, what I want you to notice on all those three null hypothesis examples is that they're all stating no relationship. As you can see, no relationship, no difference, no difference. None of them states any relationship whatsoever. Now, why is that? And that comes to the question, well, why do we need the null? Well, try to think about it. In order for you to prove what you're hoping you're going to find, you have to assume that the two are not related, because if they were related, you wouldn't be researching it to begin with. So you're always going to start with your benchmark, and your benchmark statement is always going to state no association between your variables. Now, let's take the previous example. There is no relationship between problem-solving ability and overall intelligence. And let's start pulling it apart and see why that is a null hypothesis. First of all, it states that there's no relationship. So this is variable number one, problem-solving ability, and this is overall intelligence is variable number two. Now, what you need to understand is that you need to find a way to measure both of those variables. So you're probably going to have some kind of a scale measuring problem solving ability, and you're probably going to have some kind of a test measuring overall intelligence. And then you're going to be testing those individuals to see how they're doing on problem solving. And then you will be finding certain associations between the two, right? So before you even get start doing that, though, you will assume that there's no relationship between the two. You do not have knowledge, because if you did, you wouldn't be researching it. So always, always the null hypothesis is going to be a no relationship. This is how we represent the null hypothesis. So when it comes to signage, H0, that's going to be your null. So when you're writing your research hypothesis, we don't usually say null equals. We're just going to say HO right here. And as you're going to see here, we're having a mu. It's supposed to be the Greek letter mu, but I used just the M here just because I couldn't find the mu symbol today. But anyhow, uh, the mu is the population mean, and we're using for the null the population mean. You're always stating that that is representative of your population. Now, of course, when you're going to be doing the actual research and you're going to be testing it, you're going to be having samples. But again, remember the null represents your benchmark, your existing knowledge. And your existing knowledge is that there's no relationship between your two variables. So we're reflecting that on our population of interest. So the mean of the variable 1 is going to be equal to the mean of variable 2. And I'm not talking equal in the sense of numerical value equal. The equal here represents that there's no association. Okay. Now, researchers want to reject the null. This is our dream. I mean, we invest all that money because we want to find some form of association. It doesn't matter if it's positive or negative or whatever it is, but we want to reject the null. We want to prove that the null is wrong and we are right. Of course, a lot of times that's simply wishful thinking. Hopefully, if you truly did a lot of background reading and you had a really good literature review and you probably are pretty confident about your results, you might be getting something. But of course, in order to prove that the null is false, it's very difficult. Okay, and a lot of researchers don't get the results that they're hoping to. And of course, there's other variables, as we're going to see, that play a role into that. But anyhow, our goal is to reject the null. That's all you need to remember. We want to reject that null. And that gets us to the research hypothesis. And that's what we want to prove that it's true. The research hypothesis is what we're actually trying to prove. So it has to be a very definite statement. So here you're not questioning, you're not saying, is there an association between overall intelligence and problem solving ability? No, that would be wrong. You have to say there is an association between overall intelligence and problem solving ability. You need to be very clear, very definite about what you're hoping to find. Now, every single null hypothesis has at least one research hypothesis. And I'm saying at least one because there is a way that you can state your research hypothesis a little bit differently. So you might have more than one research hypothesis. We're going to talk about that in a little bit later, okay? And that takes us to the next concept. So, research hypotheses actually come in two flavors. There can either be non-directional or directional. And what do we mean by that? Non-directional. What does the word non-directional means? It means that you have no direction, right? You can go either way. So now what I want you to imagine is the normal distribution, the normal curve. So remember, you have the hump in the middle, and then you have two tails, one going towards the positive side, the other one's going towards the negative side. So when there's no differences, that means you're somewhere in the middle, right? You're not going to be, in order to get an extreme result, right, you have to be towards the tails of the normal distribution in order to prove that something is right, okay? So if you're landing on the right side, on the positive side, or the negative side, and it doesn't matter to you as long as you're landing somewhere, that is going to be a non-directional hypothesis because you're simply stating that there is an association, but you're not stating any particular direction. You're not stating that it's going to be a positive direction or a negative direction. You're simply stating that there is an association between the two variables that you're testing. Now, in the directional hypothesis, you have to choose. You cannot say simply there is an association. You have to say there is a positive association or there is a positive difference between this and that or a negative. You have to stick with a particular direction. So if in your research hypothesis you're stating a positive association and you end up finding a negative association, you do not get to reject the null because this is not what you hypothesized. But if you simply stated an association in your research hypothesis and it landed on either side, either being positive or negative, but you have formed a non-directional hypothesis, then you would reject because you didn't predict any particular direction. You simply stated an association. And this is how it looks with simples. So a non-directional research hypothesis looks like this. So H1 is the symbol for research hypothesis. Remember, null is HO, H1 is research hypothesis. And here what I want you to see it is an X bar. Because why? Because here we're testing samples. So we're going to be comparing sample means. And here is the sample mean of your first variable, and this is the sample mean of your second variable. And you're comparing the two and they're not equal. Okay, they're not equal because you simply found some form of an association. So this is how you're stating it. You're hoping that the two are not equal because you're trying to prove that there's an association between the two. Now, when it comes to a directional relationship, you have to choose. You're either going to write this or you're going to write this. You cannot have both. So here you're going to select which direction. So you're going to say that, you know, overall problem solving ability increases with intelligence, or overall problem solving ability decreases with the level of intelligence of an individual. So you have to choose a direction. So it's either going to be the mean of the variable 1 less than the mean of the variable 2, depending how you're stating it, or the mean of variable 1 is greater than the mean of the variable 2. We're going to give specific examples when we're going to actually try to solve some problems. But for now, just simply know the difference between a non-directional. So this is how we're writing a non-directional, and this is how a directional looks like. So let's go ahead and form some non-directional and directional hypotheses. So here our null states there is no relationship between problem-solving ability and overall intelligence. How would we form a non-directional? Remember, non-directional means that it can go either way. Now, of course, once you solve the problem, you're going to have some form of direction, but you're not predicting that. Okay? So when you're forming the research hypothesis, it's pretty much your prediction of what you're hoping to find. Okay? So just in case, because once we get into solving an actual problem, a lot of you are going to say, well, but it lands on the positive side. Why it's non-directional? And it comes back to how you stated your research hypothesis. It has nothing to do with your final results. Your final results, you're simply going to state your findings where in your results section. But in your intro, you're simply going to state of what you're hoping to find, okay? So in this particular example, a non-directional research hypothesis would sound something like there is an association between problem-solving ability and overall intelligence. And for a directional one, you want to think about it? You want to take a minute? You can pause right here, think, and then I will give you an example of it, because there's different ways of solving it. And that's the other thing that I want you to know. Just because I'm phrasing it a certain way, that doesn't mean that it is the only way. Okay, there's a lot of different ways you can put a direction or a non-direction to a research hypothesis. So a directional hypothesis for this example would state something like increased intelligence is associated with higher problem-solving ability. Okay? So here I'm talking about increased intelligence, right? So people who are smarter, they have a better problem solving ability. I'm not simply saying that intelligence has something to do with problem solving ability. I'm saying that increased intelligence or smarter people are better problem solvers. How many tails? All right. So this is something that, again, some of you will get confused. What I want you, as I'm explaining here, the one tail and two tail concept, I want you to have the normal distribution in your mind, okay? So you're having the normal distribution, and remember the curve, right? It has two tails. A non-directional research hypothesis is going to have two tails, okay? Because you're simply stating an association. You're not stating direction. So it doesn't matter what your final result would be. You're simply stating that there's an association. So it can be either positive or negative. And that's why it is called also a two-tailed test. One-tailed test would be a directional one, because here you're choosing a side. It's either going to be positive or it's going to be negative. You cannot have it both. And that's why you have to land on that side of the tail when you're actually performing your test. This is actually taken from your book. I would highly recommend that you take a look. I think the author here did a pretty good job forming a null hypothesis on various examples and then giving you a non-directional two-tail research hypothesis as well a directional research hypothesis. So please do read through those examples just to get an idea of how to form a good research hypothesis, either being non-directional or directional. Now, just to reiterate a little bit, a null hypothesis deals with populations, right? But in reality, we cannot test the population, but we can infer after we're testing that the results, okay, if our sample was representative, we're suspecting that within the population something similar is happening, right? So the null always deals with population, where the research usually deals with sample. The only time that research is going to deal with an entire population is if that population of interest is very small. So imagine that you're researching a very rare disease, a disease that maybe 10 people in the entire world have it, right? Maybe it would be possible for you to perform research on those 10 people. But when you're talking for something that is very common among a lot of people, then consequently you cannot do research on all of them. You just probably gonna find the best method according to how much money you have to find a representative sample and test them, and then you're going to infer whatever results you're finding that that is true also for the population, for the general population. So, what makes a good hypothesis? This is very, very important, and please do know this slide very well. When we're stating a hypothesis, right, our statement needs to be very declarative. We cannot simply form a question. We cannot say, is there an association between variable 1 and variable 2? No, that would be wrong. We're not questioning. That means that we have done our research, we have read a lot of literature, and we're expecting to find some form of an association. And that's why we always state our hypothesis in a declarative form. Now, when we're stating our hypothesis, we also need to state there what kind of relationship we're trying to find. Is there a positive association between the two? Is it a negative association? Is it a simple association? No matter what it is, our sentences needs to be very concise. They need to have a direction or an association, and they need to be that relationship needs to be defined very clearly. We cannot be very vague, and we cannot form questions. Now, all that is going to be based on some kind of a theory or some pre-existing literature. So it's not something that, as I said before, going to wake up one day and you say, "Oh, yeah, this is what I'm going to test," because nobody's going to give you money for anything like that. When also stating a hypothesis, you need to be brief. You're not going to write an essay here. You're not going to write an entire paragraph. You're not going to, your hypothesis is going to be a simple statement. And the last thing is that your variables that you are going to be comparing, associating, or trying to find differences, they need to be testable. So whatever you're trying to prove, you need to select variables and you need to find a way to measure them. Because if you're not going to be able to measure them, there's no way you can possibly do any statistics. All right, everybody. So this is the end for today. Good job. And next time we're going to cover chapter 8. Have a good one.